Hi friends, I am Yashwardhan and welcome back to my YouTube channel. In the previous tutorial, I have explained how you can download EMU8086 EMU8086 software, and also we have done a simple program of storing some value in AX, BX, CX and DX registers. Now, in today's tutorial, I am going to be talking about the different addressing modes that we will be using with 8086. So let's get into the video. Now, the first addressing mode which we will be talking about in this video is nothing but immediate addressing mode. Let's see. Immediate addressing mode. Yeah. And one more thing friends, whenever if you want to comment any line in EMU8086, you can just include a hashtag before that line, and that line is treated as a commented line. Now, in immediate addressing mode, what we do is we directly store whatever is the value in the AX register. Suppose if we want to store a value like 7284 in AX register, we directly write a command like move AX, 7284, and as it is hexadecimal, we should mention it as capital H. Capital H. Now it is treated as I want to store a value like 7284 in AX register. Now similarly, if I want to store some value in CX register like 0004 hexa, so now 0004 value is going to be stored in CX register. Now I will include the halt command in order to halt the execution. And this is not the case only. This addressing mode is not only used for AX or CX. You can even use AL for AH also. Like you can also write move BL, comma 98 hexa. Even this command is also comes under the immediate addressing mode. Now let me first save this file. Give me a minute. Yeah, let me save this file as my tutorial 2. And also you should always remember that whenever you are storing any file in EMU8086, you should always see that it is stored in .asm format only. .asm stands for assembly language program, assembly language. So you should always store in the format only. Now click on save. Wait a minute, okay, I just repressed that. Okay, now let me run this program and show you the result. Now if you see, whenever before the execution of first line, you will see that my X is having 0000. Now whenever I run the first line, you see the AX register is updated to 7484. Now whenever I run the second line, my CX has become 0004. Similarly, when I run the third line, you will observe my BL become 98 value is stored in BX register. Now whenever the last line is run, the program is halted. So this is a simple addressing mode. The example which I showed in the previous tutorial, it also belongs to the immediate addressing mode. Now let's move on to the next addressing mode, which is direct addressing mode. Let's see, it's direct addressing mode. Now in direct addressing mode, what we do in the immediate addressing mode, what we did was whatever is the value that we want to store, we directly stored in that register. But in indirect addressing mode, what we do is we mention the memory location where that value is stored. For example, like move AX, some 4000 hexa. Now what this statement is saying that I want the program to go to the 4000 memory location and take the whatever is the value stored in the AL part. and whatever is in the 4001 location, that you take and store it in AH register. So that's how it is stored. But in EMU8086, only the offset address is not enough. You should always mention the segment address also. So you should first write a statement like move AX, 0300 hexa, which is nothing but my segment address. Now I want to store the segment address in DS register. Always the segment address should be stored in DS register or ES register. But we cannot directly assign a value into DS or ES register. So first we need to take that value in AX register and then transfer it into DX register. Now in the fourth line you see a statement like move AX, 4000 hexa. As I have explained, it will go to the 4000 memory location. Whatever is the value in that location, it takes the stores in the lower byte, and whatever is in 4001 location, it takes that value and stores in higher byte, that is in AH part. Similarly, I can also write in AX, 78 hexa. Now what this statement is saying, that in command is used to mention the input. So what we are technically saying, that go to the input port whose address is 78, and whatever is the value at that input port, take that and store it in AX register. But in EMU8086 we cannot directly write the input or output, so I am not showing that. But it will execute in the emulator. But okay. Now let's after you have written it, let's see HLT to halt this program. Now let me save it and then click on emulate to run the program. Now if you observe here, whenever I run the first line, 0300 is stored. And friends, before we execute this program, first we need to add the value in that memory location. To do that, go after you open the after you click on emulate and emulator tab opens, go to aux, go to memory. In the memory, this you change our segment address was 0300 and our offset address is 4000 hexa. Click on update. Now these are the values we will show. Here this is showing the value in 4000 location. This is showing the value in 4001 location, 4002 location, 4003 memory location, 4, 5, 6, 7, 8, 9, 4000A location, 4000B location, 4000C location, 4000D location, 4000E location, 4000F location. And afterwards, from here 4010 memory location is started. So now as we have mentioned 4000, I will mention a value like 23 and 76 here, 76. Now click on update in order to store those value. Now let us run this program. Now when the second line is done, you will observe a DS in the DS register 0300 is stored. Now whenever this line is executed, you will observe AX becomes 7323. You can observe what happened just as I explained. Whenever I run this fourth line, what happened was, first it went to 4000 memory location, whatever is the value it fetched and it is stored in AL part. And then it went to 4001 memory location, took that value and stored it in AH part. Now when I run this, you will observe, but when I run this line in AX, 78, you will observe 0000. This is because as I am using a software, and in the software I didn't mention any value for the input port, so it is by default it is showing 0000. So, and whenever I run the last line, you will observe the emulator is halted. Now I hope friends you have developed a clear understanding about the immediate addressing mode and the direct addressing mode. Now friends, let us move on to the next addressing mode called the register register addressing mode. Let's say addressing mode. Now in register addressing mode, what we do is we technically, instead of directly mentioning in the previous addressing mode, that is in direct addressing mode, we directly mention the memory location where the value we require is stored. But in this type of addressing mode, what we do is we store the memory location in another register and then we transfer the value. So we generally tends to store whatever is the value that we want to store in a register in another register and then pass it to the register. For example, this line will be the common line for AX, 0300 hexa, move DS, 4000 hexa. Move DX, AX. Yeah. Now, friends, from here on, whatever the addressing mode I will be talking about, I will be using these two lines as common lines, because for any other addressing mode, you should always mention the segment address. Then you should mention your program. So this is a segment address. Now moving on to the example, let us say first let me write an example like 75 hexa and move AL, BL. Now when you observe here, what is the main thing is that I want to store the value 75 in AL register. But instead of directly storing it in AL register, first I am showing that value in BL register and then I am passing the value in BL register into AL register. This is called addressing mode. This is very useful for example, giving the value to a DS register. DS register, if you want to give value, you will see that you cannot directly assign DS 0300 hexa, which will give me an error. So first of all we need to store it in AX register and then we pass it into DS register. Similarly, you can have one more example like move DX, 1 to A2 hexa, and then I want to store that value in CX. So just say move CX, DX. And this addressing mode is also useful whenever we want to mention two different counts. Like in CX register you mention a count, and in DX register you decrement that count and then you update the CS register. That's in those situations also this is very useful. Now let me write the halt statement. Now let me save and run this program. So as I am not giving any memory location here, so no need of assigning any memory to this. Now whenever I run this program, you will observe whenever the first line is run, 0300 is stored. When next line is run, DS register is changed to 0300. Whenever the third line is run, you will observe BL becomes 75. And whenever this line is run, this 75 is transferred to AL. But you will observe only I have mentioned move AL, BL. So only my AL is changed, but value in BAH does not change. Now whenever I click on the next statement, our DX is changed to 1 to A2, and whenever the next statement I run, you will observe my DX, whatever in CX that came into DX, and whenever the last line is run, the emulator is halted. This is the third type of addressing mode called the register addressing mode. Now you may have developed a clear basic idea about the immediate addressing mode, direct addressing mode, and register addressing mode. And friends, I want to make a thing clear is that here in order to make you understand better, I am executing line by line. But if you want to execute the whole code, you can just click on run and it will run the whole code at a time. Okay. Now let us move on to the next address. Okay. Now the next addressing mode is the indirect addressing mode. We have seen the direct addressing mode where we indirect addressing mode. Now in the previous tutorial we have seen in the direct addressing mode what we do, whatever is the value we want, we directly mention the memory location where the value we want to store is located, and we store that value. Like we write move ax comma square bracket 4000, that is we are saying that in 4000 memory location whatever is the value, store it in ax. But in indirect addressing mode what we do is, so first let me write the common lines. 03 hexa move ds comma ax. Now in indirect addressing mode what we do is that instead of directly mentioning the address to ax register, first we store the memory location or the address in some bx register, like move bx, or let us take a common example which will be most commonly used, move si comma 4000 hexa. So what we are doing, we are storing the memory locations 4000 memory location in si register, and then in the next line we are writing move ai comma si. So what we are doing, this si is a source index register. What it does is it stores this as, it is treating this as the memory location. So whenever I write move ax comma si, what it does, it only stores 4000 in ax register. But in indirect addressing mode, it should store the value present in this memory location. So you just include this in square bracket. Now what it does, it goes to 4000 memory location, picks up the value, it goes to whatever is the address pointed by si, goes to that location, picks up that value, stores in AL, goes to the next memory location, picks up that value and stores in H. And now let me write the halt statement in order to end this program. Now let me save this and click on emulate now. Now here see, whenever as I am using some memory location, first let me update the memory. Go to memory 0300 4000, click on enter, or you can click update, and here let me write the value like A3 and 8D. And in the memory location when you are typing the value, no need of mentioning any 0 between this alphabet. You can your value can start with A, alphabet from A to F also. So now click on update in order to store this value. Now whenever the first line is done, you will observe AX becomes 0300. Whenever the next line is done, DS becomes 0300. Whenever the third line is done, you will observe our SI register is storing a value 4000. Whenever the next line is run, you will observe that is whatever is in the 4000 location, it came into AL, and whatever is in the 4001 location, that come into AH. And when the next line is done, the program is halted. Now this is the indirect addressing mode. Now let us move on to the next addressing mode. Now friends, let us move on to the next addressing mode, which is the register indirect addressing mode. Register indirect addressing mode. Now in the if you remember in a few minutes back, I have discussed about register addressing mode. In that we store the value in a register and then we are passing the register to other value. Like for example, we are storing some value like 76 in BL register, and then we are writing a command like move AL comma BL. That is whatever is in BL, we are giving that value directly to AL. But in register indirect addressing mode, what we do is first this line is common, move ds comma ax. And friends, this is not a standard value that you should always store. You should always take the segment address like 0300 hex. It is generally preferred. You can take any memory location other than the starting memory location, because in the starting memory location some default programs runs. So you should always avoid taking the starting memory location, but afterwards you can take any segment location you want. Okay, now let us take an example like move bx comma 1232 hexa. Let us say, let's for simplicity let this be 2300 hexa only. Now in move, you will write a command like move ax comma bx. Now if you observe, this becomes a register addressing mode. That way you are directly saying whatever is the value in bx, store it in ax. But in register, the difference between register direct addressing and in register addressing mode and register indirect addressing mode is that in indirect addressing mode we keep this bx in square bracket. As you can guess, now it is going to the offset location 2300. Whatever is in value, store it in AL. Whatever is in the next memory value present in next memory location 2301, store it in AH. That's what it does. And next we write HLT in order to end this program. Now to also point out the difference between register indirect addressing mode and the previous indirect addressing mode is that in indirect addressing mode we are storing the required memory location in SI or DI register only, whereas in register indirect addressing mode we store the value only on the general purpose register AX, BX, CX, DX only. So that's the difference between them. Now let me save this and run this program. Now if you observe, whenever I run the first step, you will observe 0300 is showing AX, when the next step is that DS is having a value 0300. Next, whenever the next line is done, you will observe BX become 2300. Now you will observe that I didn't if I click on the next memory location, it will store 000 only, because by default in that memory location I have 000. But I doesn't want that to happen. So what I do, I go to that memory location, I change it 0300 and 2300 update. Here I will store a value like 23 and D5 and click update. Now when I run the next line, we will observe that AX become D5A3, that is 23 is stored in AL and D5 is stored in AH. Now when the next line is done, the emulator is halted. Now this is a simple program I have explained in order to make you understand register indirect addressing mode. I hope you have understood this. Now let us move. If you have any doubt or if you are doing this parallelly by seeing my video, you can always pause this video and share it and do the steps, and afterwards you can do it. And I will also keep a link to the code file. You can also directly copy and paste the code and follow along. If you have any doubts at any point of time, feel free to comment that down below and I will respond accordingly. And if you liked my explanation, please like this video. Now let us move on to the next memory location. The next addressing mode which we will be talking about is the register relative addressing mode. The next we are talking about the register relative addressing mode. That is, here it does not mention the value directly to any register, or it does not mention any value directly. We always mention the required location indirectly or in a relative manner. let me give you an example to give you more clarity. Like move, first 2 lines will be common, like move memory location hexa, move ds comma ax. This is a preferred location I prefer. You can store, instead of 0300, you can write 0310, 00400 or 1000. Anything is accepted. There is no problem in that. But if you are using any physical 8086 board, it is all you should see the manufacturer or what are the segments that are made available to you. Now in the EMU80, it doesn't really matter much. Now let us move on to the example, like move. I write a thing like move some. Now here no need of this space here. Yeah, move, let me write a statement like move bx comma 1500 hexa. This is looking common like a register addressing mode. Next I write this line like move ax, but instead, and if I write only in square brackets bx, it means only, now I am mentioning that only this becomes a register indirect addressing mode. In register relative addressing mode, we just add some value like 50 hexa before this bx register. You can write this line in this way, or you can even write it as move ax comma 50 hexa plus bx plus square bracket bx. Both these lines mean the same. Now what it does is that whatever we have mentioned a value like 1500, and here we are mentioning before the memory location of bx 50. So what it does is, what the compiler does is, it adds this 50 to this 1500, and it takes the location as 1550. It goes to that memory location, takes that value, stores it in AL, go to the next memory location, takes that value and stores it in the AH part. And let me write the last statement like halt, save this, and now when I emulate this, to make you understand better, let me just open the memory like 0300 and yeah 1500. Click on update. Here let me give you a clarity, let's say 56. Yeah, and here we mentioned bx plus 050, so it will go in 1550. Let me give you a value like 1278 and click on update. Now whenever the first line is done, you will observe ax becomes 0300, next line is done, ds becomes 0300. When the next line is icon, bx in bx 1500 is stored. When the next line is observed, you will observe ax becomes 7812. Whereas in register indirect addressing mode, if it is taking only bx, it should have become 5623, but it becomes 7812. That means it is adding this value to this memory location and going to that memory location, taking that value. Instead of this, suppose if you write 1000 hexa, move bx comma 1000 hexa, and here you give move x comma 50 h bx, then it will go to 1050 location and take that value. So now if we are you can again go back a few minutes back where I started explaining this concept. See that video if you are not understood and follow along the next part. Now let us move on to the last addressing mode. Now let us move on to the last addressing mode, which is called based index addressing mode. This is the last type of addressing mode in 8086. In here, let us say first let me type the code like move 0300 hexa, sorry 0300 hexa move dx comma ax. Okay, and always whenever you should give a space after move, then you should write a move bx comma 1500 hexa only. Next you write a command like move si comma let us say 0500 hexa, and write a statement like move, finally write a statement move ax comma bx and si, and last write the whole statement. Now let me explain this. As you can understand the first two lines, I have stored the segment address in DS. Now in the fourth line you understood that I have stored the value 1500 in BX and 0500 in SI register. Now in the sixth line you observe I write move AX comma square bracket BX square bracket SI. What it does, if you can guess what it does, it just adds these two values and goes to that memory location. That is, now it will take the value 1500 and also take the value 0500, adds both of them. If you add both of them, 0 0 0 0, 5 plus 5 is 10, which is nothing but A in hexadecimal, and 1 plus 0 is 1. So 1800 is the memory location where it will go. It will fetch that value, so it's in AL. It will go to 1801 location, take that value and store it in AX register. So to make you understand a little bit better, let me run this code and I will show you. Go to aux, go to memory 0300, let's say 1500, click OK. 1500 and click OK. Now, and here let me change the value like 2345, update, and I will also give a value like, if you calculate this correctly you get 1A00, go to update. In that memory location let me give the value like 6578, sorry 6578, and this is 00 only, update. Now whenever I run the first line, what happens? AX becomes 0300. Whenever I run the next line, DS becomes 0300. Whenever the third line is executed, BX becomes 1500. Now whenever the next line is in SI 0500 is stored. Whenever the next line is run, you will observe AX becomes 7865. That is, it went to 1800 offset location, pick up that value and store it in AL, and go to and it went to 1801 memory location and store that value. Now you may ask me, Yashwardhan, whenever you are saying that here it is showing that this is 0300 is to 1800, but when I am selecting that cell, you see the value as 04801. Why? This is because this 04801 is nothing but the physical address. That is, it is taking this physical address. That's the physical address it is showing. And if you are feeling any difficulty in understanding this like this, that is, if you are not able to understand that this is 1801 location, this is 1800 location, this is 1801 location, this is 1802 location, you can simply do one thing. Just change, instead of selecting table, click on list. Now you will see in the list value. Now this is another thing you can see. Now when I run the last step, the emulator is halted. In some codes, if you observe, you will also observe a statement like move 50 extra. 50 hexa. Now this is also a based index addressing mode, but we are also combining the previous concept of relative addressing mode. That is, we are adding, so in technically what we are doing is, we are taking 1500, adding 0500, and we are also adding 50 hexa, and totally now the compiler will go to 1A50 location, takes that value, stores in AX, and takes the next value and stores in AH. Now let me save this and run this and show you also. Go to memory location 0300 1A50 and click update. In 1A50 let me give us some value like and D6, click update. Now as I mentioned that instead of running each and every step at a time, you can run the whole program at a time. That is, you can just click on this button and the whole program is executed. Now if you observe, the value D623 is stored. That is the value that it should store. Yeah, that's what it is we need to observe. But if you are not understanding this, just click on reload. It is again go to the first line of this program. Now click on single step. You will observe AX becomes 0300. Whenever the next line is run, DS becomes 0300. Whenever the third line is run, BX becomes 1500. When next line is run, we observe SI becomes 0500. Whenever the next line is run, it will go to 1A50 memory location, take that value, stores in AL. 1A51 location, takes that value and stores in AH part. Now you may have developed a basic idea or a clear idea on the different addressing modes that we are be using in 8086. If you have any doubt related to this topic or any topic of electronics, feel free to comment that down below, and I will either try to resolve it in the comment section, or I will make a dedicated video about that topic if the topic is a little bit discussion is required. Or if you have any doubts, you can also mail your problem to the mail ID that is mentioned in the description below. If you like my explanation, friends, please like this video, share it with your friends, and if you are new to my channel, please click the subscribe button to see more such video and also see the other videos on my channel. If you have any doubts, please, I already told to mention in the comment section. And thanks for watching, friends, and have a nice day, and I will meet you again in a new video with a new concept. Thank you, friends.